Hi guys. All right, so you should have received this worksheet. It says motion video notes across the top. Make sure you write your name in the top corner so that you don't lose it. A lot of these you're going to see, they're kind of similar prompts to what you saw in your guided notes earlier today. Okay, so this should be pretty quick for us to fill in. What this is doing is showing us the difference between distance and displacement, okay? So it says here that a frame of reference is a four-quadrant coordinate system like the one to the right. Now, we're pretty familiar with this. This is a graph, right? It says that the x-axis and the y-axis of a reference frame are drawn so that they are perpendicular. Okay, what it means to be perpendicular means that you have two lines that come and intersect at a right angle, okay, just like the one we see here. So intersect, and where they intersect or cross each other is called the reference point, okay? So then it says here on this bullet point that on the frame of reference, which again, that's the coordinate system here, you are going to circle where the reference point would be found. So I'd like you to take a look at this system and go ahead and circle where the reference point would be. All right, so our reference point would be right here because we know that that's where the two lines intersect, right here, okay? So I'm going to write a little note here to myself that this is called a reference frame. And then this right here is called a reference point, okay? Now don't forget everything that I write down. That's important information. You should also write that down on your notes, okay? All right, so then you have this question here. It says, how are displacement and distance different? We're going to start with distance. Distance, this simply measures the change in position of an object. So we'll say change in position of an object. Okay. Now displacement is very similar to what distance is, but the difference here is that it's the change in position and direction of an object. Okay, so these two terms are actually very similar, but when we write displacement down, we're always going to include a direction. And when we talk about directions, we're talking like north, south, east, and west. Okay, so we're going to be using something called a compass rose to kind of help us out with that. Okay, so go ahead and turn the page. All right, so here we are going to use the frame of reference to the right. So this is a frame of reference. And we're going to consider the following scenarios. And we have 3 different scenarios on this page. I know it looks like a lot of writing, but that's okay. We're going to say that the reference point is our house. And I'm going to make our house just a circle, just like this. And I'm going to color in that circle. So this is going to kind of act as my key over here. Whereas this right here is where I'm going to draw everything out. So I'm going to go ahead and plot where my house would be. I'm going to label it as my house. Okay. All right, so our first scenario is getting groceries for grandma. So we're going to plot a point that's 2 kilometers south, and it says up here that every square on our frame of reference is a 1 kilometer by 1 kilometer city block. Okay, so every single square counts as 1 kilometer. So we want to plot a point that's 2 kilometers south of our house. If we remember what a compass rose looks a little something like this. We got north, south, west, and east. Okay, I almost messed up there. All right, so you're going to plot this point that's 2 kilometers south. If we go 2 kilometers south of our house is here. We're going to go 1, 2. This plot is going to be our grocery store. So I'm going to draw a grocery store. Now, my drawings are going to be very simple because we have a lot of drawings to do on here. But I'm also going to label this grocery store. I'll leave a little room here because we have another label going here. Then it says plot a point 6 kilometers south of your house. This is Grandma's house. Okay, so from our house, 1, 2, 3, 4, 5, 6. Okay, this is Grandma's house. We're going to make it cute because Grandmas have cute houses, right? There's Grandma's house. And again, I'm going to remember to go ahead and draw everything I just drew. So I have a nice key to look back at. So our scenario says that we're going to start at our house and then we're going to walk to the grocery store. So once you grab the groceries, you walk to Grandma's house. Okay. What would the total distance be that you traveled? What would that be? Okay, so I would like you to answer that in kilometers. Take a moment to do that. How far did we travel to get to Grandma's house, even though we stopped at the grocery store? Okay. The next question is talking about displacement. You might not see a lot of difference in this, okay, and you'll see a difference later. But how far is Grandma's house from your house? So you go here, go ahead and see how far away that is. And you're going to write that in blank kilometers. But remember, the distance and displacement are different because displacement also tells us the direction. So tell me, what direction were we heading when we went to Grandma's house? Okay. All right. So we're going to go on to our second scenario. So I apologize. We're going to keep flipping from here back up to the frame of reference, just so you guys can see what I'm drawing. It says plot a point that's 3 kilometers west of your house. This will be the ice cream shop. And I'm going to actually make my ice cream shop look straight up like an ice cream cone because, come on, that's iconic. And then it says to plot a point that's 4 kilometers east of your house. And this is the location of Bobby's house. Okay, Bobby's going to live in, let's say he lives in a castle. Okay, so we draw a castle. Actually, it looks more like a Tetris piece, but you know. All right, so if we go over here, we want this 3 kilometers west. So west is to this side of our frame of reference. So 1, 2, 3. Okay, that's where I'm going to draw my ice cream shop. Oh, sorry, I apologize. It keeps blurring out. And then over here, we have our castle, which will be Bobby's house, and that's 4 kilometers east. Okay, so 1, 2, 3, 4. So I'm going to go ahead and draw Bobby's house right here. All right, so let's read the scenario. Now that we've plotted these two, I'm going to go ahead and label them too. Bobby's house. And then right here we have our ice cream store, ice cream shop. All right. So you decide that you and Bobby are going to hang out. So you walk over to Bobby's place. So we're starting here and we walk over to Bobby's. So we're going to start that over again from here. All right. After a few rounds of intense video games, you and Bobby decide that it would be a good idea to grab some ice cream at the ice cream shop. Okay, so you're going from Bobby's all the way to the ice cream shop. Okay. So then it says, how far did you walk in total today? So think about that's from your house to Bobby's house and then all the way to the ice cream shop. So how many kilometers did you travel? All right, and then you also have to talk about your displacement. It says, how far is the ice cream shop from your house? So we're not even talking about Bobby's house. We're just seeing how far the ice cream shop it is. Okay, so how many kilometers is the ice cream shop? And don't forget, there has to be a direction. In what direction is the ice cream shop from our house? All right, so our last scenario is going to the library. So if everyone could follow along on the bottom, we'll go back to our frame of reference in just a moment. It says plot a point that is 3 kilometers north and 4 kilometers